Hello everybody, and welcome to this video about creating an API, in this case with Golang, and then using it in a PowerApps application. Now, what you need to know to actually do this video, it's meant for, let's say, beginners. You do have to have a little bit of experience with Golang, a little bit of knowing what Kubernetes is and what you can do with it. And yeah, a little bit of knowledge about Power Apps, but that's rather low. And what we'll do is the following. We'll actually create an API using Golang. We always see examples of using a .NET API. We'll do it a little bit different here. So we'll create the API using Golang. We'll then build the API, package it up in a container, push the container to Azure Container Registry, and then actually create a Kubernetes deployment and a service to host the API. Then we'll create a custom connector in PowerApps, use that custom connector in a Power App application, and then basically call the API from the Power App, right? Now I'm recording this video with the least amount of edits as possible, and as you know, when you're building something, you can have some issues once in a while. You forget a command, you mistype something, and so on. I'm purposely leaving that in, so when I make a mistake, you'll see the mistake I make, and hopefully you will avoid that mistake as well. Let's not try to make it that perfect, because I don't think in real life it's going that perfect all the time. Now good, how do we build the API? We'll build it using Goa. So Goa is an easy way to build an API using Golang, and it uses a design first approach. Yeah, first of all, of course, you have to implement or install the packages that you require. So Goa and Go again have to be installed on your system where you already installed Golang. I had an issue with Golang 1.7. I still had an old version of Golang on my system. Make sure you install the latest version of Golang. In my case, I think it's version 1.9. If I'm not mistaken, let's take a look. So Go version. Yeah, indeed. So Go version 1.9.2. And after you installed the Goa packages, you can start designing your API. So what is designing an API? What does that look like? Well, basically you will create a Go file with a package called design, and then using a DSL specifically for Goa, you describe the API you're going to build. Then using a code generation tool, the code to actually implement the API will be built for you. So let's see how that works using Visual Studio Code here. Having a folder called crypto, and in that folder, of course, you see some generated files already, so don't look at those. But you create a design folder. Within that folder, you create a design.go file, and in that one, you're going to define your API, right? So the API is doing, you need two dot imports there. Now, normally you should not use dot imports in Golang, but for this design package, it's quite okay. And then it's all quite simple, really. Well, for a basic API, it's all quite simple. You define the API itself using this construct here. So I provide some metadata, title, description. I can set the scheme, I can set the version, and also, for example, course settings. Course policy can be defined as well within the API directly. Yeah, then you define the resource or resources you're going to work with in this API. We are actually going to build an API that works with cryptocurrencies. So we'll be able to request the USD price or BTC price of a cryptocurrency, and that information will come from coin market cap. So we define a resource called currency, based by the /currencies. And then we define an action there. The action in this case is the show action. And when I'm going to my API / currencies / and then I provide a currency ID, which is a parameter defined here, which is required as well. Yeah, my code will actually pick up the information about that currency from CoinMarketCap and either respond with OK or with not found. For instance, if I provide a wrong currency name that cannot be found at CoinMarketCap. These responses are built in. You can also build your own responses. But here we state that, okay, we can respond with OK or not found in our implementation. Now you also have to provide what you will return. So in this case, it's called a media type or media. In this case, we define currency media, and we set currency media as the default media for the resource currency. And in this case, we just define some attributes that we'll return, like the ID of a currency, Neo or Ethereum or Cardano, whatever currency you like, and the name of the actual currency, the BTC price, the USD price. And also we have to define a view as well to define what we return when we return this currency media. Now that's basically it. So that's the design of the API, which you're now going to generate with Goa again. We'll do Bootstrap. Yeah, so normally you'll do Bootstrap because you don't have anything generated already. And then we define the folder, and it has to be a folder somewhere in your Golang path. So in my case, the folder is called crypto, and I specified that I have my design package in the design folder. So you could call it something else, but the convention is to call it design. And then we'll actually do the bootstrapping. You see something happening there. Some temporary files are being generated, and the files are created. So what he'll do is he'll create something in an app folder. See it here. Oh yeah. Wait. I have something which is saying crypto swagger access is denied. Let's take a look. What is the reason for that? Okay, well, we'll just open it up from here, and yeah, we'll do Goa again. I told you it's not edited, so D, and then crypto design. Go again, that will not work. So go again, bootstrap, and then let's see what it does a second time around. And otherwise, I'll open an elevated prompt to actually do this work. Actually, never had this error before, but as you can see, we got through it from this location. Okay, so what you'll see now is you have the actual app files generated, context controllers, and so on and so on. Don't have to worry about that code. Some Swagger is generated, so indeed later with PowerApps we will have to supply the Swagger JSON file, and yeah, Go again is actually defining this for you, so that of course makes it easy. Of course, in .NET you can also do this with Swashbuckle and so on. So that's not really unique to this kind of tool. It also generates a tool, a command line tool that you can use to actually test your API using a CLI. We'll get to that later. And then you also generate, and that's important, of course, a main.go. The main.go is basically spinning up the HTTP listener and so on. And do note, in my case, I put the API on port 80. I had some issues in the past by using these non-standard ports when I create the custom connector in PowerApps. So we'll just define it at port 80. No HTTPS here, so plain and simple HTTP. Let's not complicate it too much. And that's it. So if you see that you made a mistake and you put it on port 8080, just define just define this in your main.go, the port that you want, and that'll be fine. Then our actual implementation is done in currency.go. Currency.go does a couple of imports. So crypto app, which is actually what was generated here. Of course, the Goa design packages. And in my case, I also defined another package, a Golang package that implements the CoinMarketCap features. I didn't have to write this myself, easy. Call this Coin API. And then in the actual implementation of the code, which is kept really deliberately simple, we check if you have a currency ID. If not, we return a not found. And we'll get that error when we call the API. If you have a currency ID, we actually call the coin API with the currency ID as a parameter. That goes to CoinMarketCap and gets the data from CoinMarketCap. We check if you get a return. If you don't get a return, a proper return, we say not found. And otherwise, we basically return what Goa does here. It created a type Goa example currency, which we can use to actually return the proper result for this show action. So the ID, we just return the currency ID that we pass as a parameter, the name that we got from CoinMarketCap, so the actual longer name of the cryptocurrency, and then we return the BTC price and the price in USD that we get from CoinMarketCap, and then we return that result with an OK. That is basically it, and that's all you have to do here. Now, to just test this on our local machine, we'll just build the application, go build, that creates a crypto.exe file here. So it now has a HTTP server listening on port 80. And if we're going to, and that's maybe an interesting one, if we're going to tool, and then we go to crypto CLI, and we just run go build here, the crypto CLI.exe will be built. Already had one, but just to show you how to build it, crypto CLI.exe can now be started, and it actually says, okay, how you can use this now. By default, it goes to localhost. So if I'm saying crypto CLI.exe, and I'm saying show currency, that's my resource, and then currencies slash and then a currency name, for example Neo, he actually does it. He goes to my to the API running on localhost. It says 8080, but that's actually not correct. He goes to my no, actually I made a mistake here, because I think I have a Docker a Docker container running here. So I'm gonna do Docker kill, because this is one still running on 8080. That's from an old trial. So I'm just gonna kill that one. You'll see that this one will not work because it goes by to 8080 by default. So if it's not running on 8080, you would have to use the -h and then say local host and then .80. And what you'll do now is, and of course I have to make sure that I type this properly, which I did not. And now I'm going to the actual running API, which is running here. And you can see that indeed he got a request for getting the price of a currency called Neo. The currency ID Neo is logged, so logging is implemented by default by using Goa here. And he shows perfectly, okay, I got an action show on the currency controller, and status is 200, so we replied correctly here. This is great. This works properly here. Now we actually want to build a container from this, and this container, of course, will run on Linux. So go build on Windows, that's not gonna work. So we're just going to build it for Linux. And I'm going to use this one here, which is actually a command you can use for statically linking during the build phase. I'm going to run this in git bash because I'm using the environment variables on the same command line here. It makes it easier. I'm going to paste this, and I'm going to actually build the crypto executable here, crypto, which is a Linux executable, building that, and I will use that one in the container I'm going to build, right? So to recap what we've done, so we build an API using Goa by just designing the API, run some code generation tool which generates code for us. In the implementation, in our case that's currency.go, in the implementation we implement the action, the single action that was defined in the design, and then to test it we just run locally the crypto.exe after we do a Go build. We can test it with a crypto CLI tool, which is also provided in this case by Goa. So that's pretty neat. And now we just build a Linux executable for this code as well. Now, let's build the Docker file, or let's build the Docker image. And the Docker file is again kept deliberately simple. We're using the Golang Alpine image to start. We just add the crypto executable to the root. Yes, I know. And then to actually execute the code within this container, we just use the cmd command there, and we just execute /crypto. So yes, very simple, maybe not at all how you maybe would do it in reality, but this gets us off and working as it should. This is a very, let's say, a very simple Docker file to create your Docker image. Of course, to be able to build it on your local machine, you have to have Docker for Windows installed. But once you have it installed and you have the code as you see here on your system, you can easily build it. Now in my case, I already had it built, a Docker image. I'm going to use the Azure Container Registry, and that one is called, that is this name, gebareg.azurecr.io.crypto, so the /crypto. So the tag I'm using for this container image is going to be that one, because we need that when we upload our container to the Azure Container Registry. And of course, I'm going to build what's in the local folder. So we'll build that container. He successfully built it. Thank you. That's great. And of course, we would like to test this as well. So we're going to use docker run -d. Well, the port is 80, but let's just show you how you typically do this, how you map from port on your PC to port on a container. In this case, it's simple. It's just 8080. And then provide the actual container, which is this one. That's running now. So if I'm now going to the same crypto CLI, goes to localhost 80, which is now the code running in a container, I should get the same result, and I get the same result. And it's very nice. The USD price of NEO is $144. That's perfect. Okay, so the container that runs. So let's take a look. It's running. Yeah, let's do docker kill. Yeah, just kill that one. I don't need it. Right. So the service is not running anymore. Now I would like to actually put this container in the Azure Container Registry. I made that one before. So in my Azure subscription, I have an Azure Container Registry defined, and with the as ACR login tool, and then -n for the name, which is in my case gebareg, I can actually log in to that container registry, and then the docker push command can be used to push the image to the Azure Container Registry. So let's do this. Now, maybe an interesting thing to note here, and that's something that might help you in your own travels. Let's wait and see what the result will be from this tool. Um, will take a while, but it should normally error out, at least what I was getting before. So let's see what it does. Ah, no, login succeeded now. Well, actually, I updated the as tooling yesterday with the older as tools in PowerShell. I got a weird error that I couldn't actually log in. So if you have that, either run this command from a command prompt or make sure you have the latest versions of the Azure CLI. This is great. I think yeah, that problem has been solved. So I'm now logged in to the Azure Container Registry. Yeah. Now we can just say docker push, and I'm gonna push that one. It will be gebarech azurecr.io/crypto. That's the name of my image in my local image repository. And if I'm using that name and I'm using that name with docker push, he knows, well, actually, you want to go to, not to docker help or something, but you'd like to go to your own private registry where you've logged in, and that's how we actually do it. So let's try this. Docker push. He says, yeah, that's a repository, in this case, the one in Azure, and it has been pushed there, right? If you do ACR, you can actually get your repositories displayed. So as ACR repository, and you'll actually have to do, in this case, yeah, we'll do list. And let's take a look, and then the repository, the name of the registry was gebarech. I'm not mistaken, this is the right command. Yeah, and there you see I have a couple of repositories there. One of them is the crypto repository, right? So it's there, which is fine. Now, I'm also having a Kubernetes cluster running, and kubectl has been configured on my system. So I'm having a Kubernetes cluster running AKS with 2 nodes, version 1.7.7. And I've defined here as well, there's a crypto.yaml file, which actually defines a deployment. Deployment has a metadata, has a name called crypto. In this case, we are not having multiple replicas, although we could. It's completely stateless, so you could have multiple replicas running on the different nodes here. Yeah, so basically, I could change this and put it at 2 replicas. Then we're going to have supply the template for the pods that have to be deployed. We call the app name here is crypto, and then the container specification refers to, in this case, the image in our Azure Container Registry, container port reference port 80. Now, because the Azure Container Services, or AKS, has been deployed in the same subscription as the Azure Container Registry, and the service principal that was used, so the account basically that was used to deploy AKS, has contributor rights on the subscription, it can also log in to Azure Container Registry and retrieve the image when deploying the pods on Kubernetes. Yeah. Now, how do we deploy the pods? Well, very simple. Or how do we deploy the deployment? We just save this file here, so the crypto YAML file, and we do kubectl apply -f, and we do crypto.yaml, right? This will do the actual deployment. Let's do kubectl get pods to see that he's actually doing it. And because he had already some version of the image running, you see there the crypto pods are running there. If we do kubectl logs and we're asking for the logs of that pod, you'll see that in there he's listening on port 80 for incoming requests. Yeah. So if you're doing kubectl get deployment, you see we have a deployment crypto here, but I cannot reach it. I don't have an IP to actually reach it. So we're going to expose it. So kubectl expose deployment. And by the way, this could be defined in the YAML file, the same one or a separate one. I'm just showing let's say imperative command to do so. Normally you wouldn't do it. So kubectl expose deployment, and we're going to use the type --type load balancer. So there's integration with Azure load balancers here, and that means that actually a load balancer in Azure will be configured that load balances between our two pods that we just deployed. So let's do this. What did I do? Expose deployment. Of course, we have to expose the deployment crypto, and he's doing that. If we then do kubectl get service or get svc, that's also good, and then watch to actually watch the changes, you'll see that the crypto service, which is of type load balancer, is actually pending when it comes to the external IP. So we can wait a moment here, and when that external IP comes up, we can actually test it from our CLI here. And just clean it to make it a bit nicer. And in this case, we can just put ourselves ready to paste the IP address of what was deployed here. So let's take a look what happens. Here it is. So the IP address is this one, right? Did I actually copy it? Let's see. Yeah, there we go. And yeah, that's really working well here, right? So we're getting the actual responses from our service in Kubernetes. And if we're asking for the logs of one of our containers, probably it will have to be the other one, which is that's nice. So kubectl get pods, kubectl get logs, and we'll kubectl logs, and there we go. And we went to that other one over there. Right, so this is actually great. We have our service running in the cloud on a Kubernetes cluster, so that all works rather well. Let's see how we now get access to this from PowerApps.